Welcome along to Obsession Engineering. That is a 748 Ducati, and today I'm going to attempt to check the valve clearances in it. The bike is slightly in bits already because it came to me as a non-running bike, and there is an ongoing project for this, but I decided to do the valve clearance check video separately because, well, frankly, because it might make an interesting video on its own. Next thing to do then is put some gloves on and actually delve inside the Ducati. So the Desmoquattro valve train that is in this engine is the same system that is in ST2s, ST4s, 916, 996 and even 851s and 888s before that. So there's quite a big range of bikes that have this system for the valve actuation. But the first thing I need to do is take the fuel tank off, the airbox off, and realistically, to get to that inspection cover there, I'm going to have to take the radiator off as well. So I will crack on with all of those bits, and then when this bike is in more pieces, then we'll get into the nitty-gritty bits of the valve clearance check. To keep myself suitably hydrated while I work on the Ducati, I've mixed up some Holy, and today I'm on the raspberry and vanilla iced tea. And so I drink that basically instead of cordial because it's really fruity, it's a really nice flavour. Because it's actually made with a real tea base, you get all the antioxidants and bits that you would get in tea, but without that brownness that I'm not a great fan of. And there's a whole list of vitamins and minerals and bits like that that are also in here. So if you don't know Holy, they don't just do iced teas. There are caffeine-filled energy drinks, there's some really good hydration drinks, there's even some milkshakes. If you would like to get some flavour in your life and some nutrients to go with it, get yourself involved with Holy. I will put a link in the corner where you can get a discount code so you can join the Holy Squad too. Some of the jobs on these old 748s and 916s are incredibly simple. Taking the radiator off, just nice and easy. There is in fact, a few hoses and then there's only one bolt on the other side and then everything just slides off. Really easy to get to, really easy to take off. Airbox again, nice and easy to take off. The people who designed this built this like a race bike to be taken apart regularly, which is convenient because today and yesterday I am taking it apart regularly. I've also taken off the battery cover again. I've done that previously in the project, and that is so that I can get to see where the cams are positioned because that's going to be useful. To do a valve clearance measurement on one of these engines, you need to be at top dead center on the compression stroke because it puts all the rocker arms and all the cams in exactly the right place to measure the clearance. On a normal sprung engine, like a valve sprung engine, not a Desmo engine, as long as the cam is on its base circle, as in the rocker arm or the bucket is somewhere on the base circle of the cam, you can measure the clearance. On these engines you have to be in a specific point, which is top dead center on compression stroke. So you'll actually notice there is a screwdriver in there. That can be really useful for making sure you're at the top of the stroke, and just whipping the cam covers off, the cam belt covers off, will show us that these marks line up, which means that the cam on this cylinder is at top dead center. So basically you could be at top dead center on the exhaust stroke, or you can be at top dead center on the compression stroke. Making sure the cams are in the right place means that the thing is on compression stroke, so that will make life easier. If you're not sure if that's top dead center or not, as you turn the engine over, obviously this will go forwards and backwards, in and out with the piston going up and down, but I am confident that that is top dead center on compression stroke. So to turn these engines and get them onto top dead center, you take this little inspection cover off. There is an M8 hole, so you need an M8 bolt and a lock nut, and then you can turn the engine round with this bolt. And when you're in the right location, there is a little indicator there, a little arrow, and a mark on the actual pulley inside there. And between those, when those two are lined up, you know you're at top dead center on the front cylinder. So now that we're in the right position, what I need to do is take off the inspection cover here, and annoyingly the one down here, so that I have to work upside down, and that means I've got access to the valve train, the rockers and the tops of the valves, and that means I can actually get in and check the clearances. For the next step, I'm going to need some sensible things. The bit in the workshop manual that tells me the clearances. I'm going to need a piece of paper to write things on. So this is for the front cylinder, the horizontal cylinder, whatever you want to call it. And this one, obviously, normally you'd have 4 points, 4 valves per cylinder. But this one, of course, being Desmo, has opening and closing clearances. So we have 1 piston, 4 valves, 8 clearances to measure, just to make life complicated. And that means I'm also, of course, going to need some feeler gauges. So I've got all of those and a torch because seeing what you're doing is slightly awkward in these engines. It's been a while since I've had to do valve clearances on a Desmoquattro motor, and it took me a little bit of head scratching to remember how to do it, and then a bit of time on the internet actually reading how to do it properly. The workshop manual gives you basically the clearances that you need, doesn't necessarily give you the instructions on how to get them. I've decided it was easier to take the throttle bodies off and sort of push them to the side, so that I could take the little stubs off, like the inlet extensions that go to the throttle bodies, and that means I've got much easier access into the inlet side. And while I've got some reasonable access, I think this is the time to show you how to actually do the measuring. So this is the little hole that you have to work through to get to do the actual valve clearances. So basically we've got the opening lobe. So this one is pushing the opening rocker down and opening the valve. And this is the closing lobe. So this one, there's a basically a rocker that sits all the way underneath it with a little forked end and like pulls the valve closed again afterwards. And so the clearance of the distance between the two lobes is the really important bit, and making sure the valve's actually on its seat. So it's a little bit of a complicated setup, and all the way down the back of here there is also a spring, so that the closing rocker, the one that's doing that, actually at like low RPM and stuff, actually leaves the valve sat against the valve seat and doesn't just sort of rattle around freely. And so even though these are not a valve sprung engine, there is still a spring to hold the closing rocker into place to make sure, especially at low RPM, that they actually completely closes the valve. So if we have an even closer look, opening lobe, closing lobe, that's the opening rocker, and then on the top of the valve, just there, that is the opening valve shim, and the sort of slightly odd sort of big ring that sits around the valve, that is the closing valve shim, and then you can see just the forked end of the closing valve rocker, or the closing rocker arm, and then down the bottom of there you can see the return spring that just holds the closing rocker closed. So what we need to do is we need to get a feeler gauge and slide it in this little gap here, and that will give us the opening clearance. Feeler gauge, and what I'm going to do is slide that down there, and that should slide relatively easily between the rocker, the camshaft and the valve. The way I'm holding the camera, I'm having to do this left-handed, and I'm not left-handed, so that is a feeler gauge that slides in pretty easy. So what I need to do is just know the measurement for that feeler gauge. And then comes the even more complicated bit, because down here in the shadows I need to take a socket or a screwdriver or something and actually push the closing rocker arm all the way down, and I can feel a tiny bit of like almost a click there as the rocker arm moves against the spring. So the idea of me pushing the socket against the edge of the closing rocker arm is that it loads the spring up and basically lets the valve go loose, so that it's pushing the rocker arm, the closing rocker arm, against the closing lobe, and that means the actual valve is free to move, which means I can put my feeler gauge in the same place between the opening rocker and the valve top. I can put that in the same place again and measure my clearance, and that gives me what is referred to as the loaded clearance. So the opening clearance that I measured a moment ago, that is the unloaded clearance. Once this is pushed against the spring pressure, that's your loaded clearance. So this still sounds a little bit complicated, and I can't actually show you because I've run out of hands, but you have to take two clearances in the same place, one of them just as everything sits naturally, and one with the spring pushed so the closing rocker is against the closing lobe, and the two together give you the two clearances you're looking for. So I actually ended up redrawing my diagram, so I've just got 4 valves. It made my life a little bit simpler, and if I'm honest, I made a mess of the first one. So what I've got here is 0.14. That was my cold opening clearance. My unloaded clearance was 0.14. My loaded clearance was 0.3 of a mil. And so the difference between those, which is 0.16, that is my closing rocker arm clearance. So that's my opening rocker arm clearance, that's my closing one, and that's the loaded up clearance measurement. And so it does all make sense because you have to add the two together to get that one. Trust me, it does all work. And then I can refer back to this and check that everything is in tolerance. So I've taken all the measurements for my vertical cylinder. It did take me a little longer than I planned just because, well, these things take a bit of remembering how to do. And so I've checked them against the measurements down here, and actually my inlets are a tiny bit small compared to what it says for the 748, but we're well within the limit, and to be honest, the issue I thought we might have was rocker arms failing, and if the rocker arm wears, the clearance will get bigger, not smaller. And so on the vertical cylinder at least, I know my rocker arms must be in reasonable condition because my clearance is correct. And therefore I'm not going to worry too much about the fact we're a tiny bit under the ideal because we are still within the actual limit. So having now done the clearances in the vertical cylinder as well, those ones are also in tolerance. Hopefully that has been a useful guide to you if you're doing valve clearances on your Ducati. I wish you luck. It is awkward to say the least, but that is a job done on this one. And so the next thing I need to do on it is to try and make it work. And so if you'd like to see that bit, click the link in the corner. That will take you to the rest of the project. So thanks for watching, and join me again next time for some more motorbike fun.